Paper 6, main knowledge in paper 6. Laboratory operates. This is the first question that we have, laboratory operates. For laboratory operates, we have some equipments that be used for measuring volume, for pipette, burette, and measuring cylinder. What's the difference between pipette, burette, and measuring cylinder? You will find that pipette, the smallest volume that will take till 25. Then burette, 50. Measuring cylinder till 100. And then pipette and burette are accurate, while measuring cylinder inaccurate. But the measuring cylinder have advantage and disadvantage. Advantage that measure quickly or fast, and disadvantage inaccurate. Then we have difference between watch glass and evaporating dish. This is a watch glass and then evaporating dish. Watch glass can be used to take sample of the solids, while evaporating dish used for crystallization. For graduated cylinder or measuring cylinder and gas jar, the difference between them, measuring cylinder contains scales to measure and collect the volume, while gas jar without scales. Also for tap funnel and cystal funnel and burette. For the burette, it contains scales. Without scales, it's called tap funnel or separating funnel. And if it contains funnel, it is called cystal funnel. So for watch glass and evaporating dish, there is comparison. Pipette, burette, and measuring cylinder is another comparison. For burette, tap funnel or separating funnel, and cystal funnel, burette with scales. Without the scales, tap funnel or separating funnel. If it contains funnel as sub, it's called cystal funnel. These four laboratory operates as the beginning. After that, we have safety precautions, and we said that for safety precautions, if we have harmful gas or toxic gas, we must have well-ventilated room or fume capote. Well-ventilated room or fume capote. And then, if we have acid, base, or salt have corrosive effect on the skin, lab coat, wearing gloves, goggle, like that. If we have anything flammable, we must have water bath. For separation methods, you must have, number one, for filtration. Filtration can be used if we have soluble and insoluble salts. For soluble and insoluble, the soluble will be filtrate, and the insoluble will be residue. To obtain crystals from each one, the residue must be washed with distilled waters and dry, while the filtrate, crystallization. And this crystallization, 4 steps: heat, cool, filter, then dry. Heat the solution till crystallization point, allow to cool, then filter, and then dry. How can we know that crystallization point had been reached? Mixing with glass rod, crystals form. And then the drying between 2 filter papers to prevent melting of the crystals. So this is the first one, filtration. And you must know the drawing with labeling. For filtration, we have filter funnel, then filter paper, residue, filtrate, and beaker. The beaker, you must know the drawing and labels. Filtrate, funnel, filter paper, and residue. This is number one for filtration. And for that, how can we know this is soluble or insoluble? You must know insoluble salts. For insoluble salts, we said for chloride, silver, and lead. Sulfate, barium, calcium, and lead. Carbonate, all except sodium, potassium, and ammonium. This is the first one. Number 2, distillation. And it depends on different boiling point. And for distillation, we have evaporation, then condensation. We have simple distillation and fractional distillation. We can be used simple distillation in case of soluble solid in a liquid or two immiscible liquids. Immiscible like insoluble. But in case of solids, we said soluble and insoluble. In case of liquid, we said miscible and immiscible. So soluble solid and liquid like seawater or salt solution, while two immiscible liquids like ink and water. The ink will make diffusion in the water. The water will be colored by the color of the ink, so it is immiscible. While in case of fraction distillation, two or more miscible liquids like petrol or crude oil, ethanol and water, or aqueous ethanol will be colorless solution. Liquid air. Air will be separated by diffusion, while liquid air by fraction distillation. And the difference in drawing, fraction distillation contains fractionating column, while simple distillation doesn't contain fractionating column. But both of them contains round bottom flask and thermometer to measure the temperature, condenser to cool and condense the vapor. And for the condenser, you'll find that we have water in and water out, and then can be used to measure and collect the vapor. For the condenser, make condensation to cool and condense the vapor. Sometimes we have beaker contains ice, and then the tube will passing through it. This is used as a condenser. The ice is passing through the solution or the vapor, used as a condenser to cool and condense the vapor. After that, for crystallization, how we can make crystallization. At the beginning, heat the solution till crystallization point. Allow to cool, then filters and dry. At the beginning, number 1, heat solution till crystallization point. How can we know that crystallization point had been reached? Mixing with glass rod, crystals formed. Allow to cool, then filter, and then dry between two filter papers. Why you dry between two filter papers? To prevent melting of the crystals. And then, for example, if you have aqueous copper sulfate, if we need to obtain copper sulfate crystals, so you must make crystallization. If we need to obtain water from aqueous copper sulfate, so we need distillation, simple distillation. So if we have aqueous copper sulfate and we need to obtain copper sulfate crystals, so it will be crystallization. To obtain water, so simple distillation. Then chromatography. For chromatography, you must know the drawing and labeling. We have chromatograph paper, then baseline or origin line, solvent front, spots, beaker, and solvent. This is the baseline or origin line, solvent front, spots, solvent, beaker, chromatograph paper. After that, the baseline must be drawn with pencil or graphite and soluble in water. So baseline, drawing with pencil and soluble in water. And then the baseline must be above solvent. To prevent dissolving the spots. Then we're adding locating agent sometimes in case of colorless solutions. We are adding locating agent. Why? To see the spots more clear or to be more visible. After that, we are measuring our F values. So how can we making chromatograph paper? At the beginning, you must know that if we have, for example, solids, amino acids, or protein, or like that, when making crash with mortar and pestle, then adding water, then or organic solvent according to its soluble in water or not, then make filtration, then chromatograph. Again, for chromatograph paper, for example, if we have green leaves or amino acids or anything, at the beginning, you have mortar and pestle, crush with mortar and pestle. This is number one. Number two, add solvent. For the solvent, water in case of inorganic, while in case of organic, ethanol. This is number two. So for number one, make crush for mortar and pestle, and then add solvent. Number three, filtration. Number four, take sample of solutions on the baseline. After that, immerse chromatograph paper in the solvent, while the baseline must be above, then comparing our F values. This is number five. Immerse the paper, the chromatograph paper, in the water, while the baseline must be above. Then adding locating agent if the solution colorless. Add locating agent if the solution is colorless. Number 7, compare distance by RF values. Okay, so for chromatograph paper, at the beginning you have a solid, then crash with mortar and pestle. Add solvent. For this solvent, if you have inorganic material, you're adding water. Organic, so you must add ethanol. Like green leaves, this organic. Amino acids is organic, so you add ethanol. After that, make filtration. Take a sample of solution. There is a filtrate. The solution, this solution is the filtrate. On the baseline, make drops, and then immerse chromatograph paper in the water while the baseline must be above. Add locating agent if the solution is colorless. Compare the distance by measuring RF values. After that, for making salts, how can we make the salts? We have 3 methods for making salts. First one, neutralization or excess method. Number 2, titration. Number 3, precipitation. For the first one, neutralization is formed between base and acid. This base can be metal or metal oxide or hydroxide or metal carbonate. And then you will find that this metal will be transitioned. So metal, metal oxide, metal hydroxide, metal carbonate in the form of solid state, while acid will be aqueous. So this will be transition. Like if we have the reaction between copper oxide and hydrochloric acid, for example. This is solid and this is aqueous. And in case of metal, the metal must be more active than hydrogen. This is the first one. For second one, titration is formed between alkali, not base, so it is aqueous, and acid, aqueous. This alkali in group 1 or group 2.
Hey, doctor, my internet cut off, so can you repeat the first part again?
First of all, I'll explain them now, all, but I make summarize first. Okay. For alkali and acid, alkali aqueous and acid is aqueous. So aqueous, it means that in group 1 or group 2, while base must be transition inside. And then in this case, you will find that, like for example, the reaction between sodium hydroxide and the hydrochloric acid, both of them are aqueous. For the third method, that we have precipitation, is formed between 2 soluble salts mixing together to form soluble salt and insoluble salt. For the soluble salt, we'll make crystallization. For insoluble salt, wash and dry. Wash with distilled water and dry. Like if we have a reaction between sodium chloride, aqueous, plus silver nitrate, aqueous, gives sodium nitrate plus silver chloride. This is aqueous and this is solid. So 2 soluble salts reacting together or mixing together to form soluble salt and insoluble salt. So for the first one, neutralization. For neutralization, how can we make the salt? For example, if you have copper oxide and you have hydrochloric acid, and we need to obtain a salt of copper chloride, and you have 6 marks for this question. How can we obtain copper chloride crystals from copper oxide and hydrochloric acid? As a beginning, we are making like that we have Bunsen burner, and then you are putting the acid inside the beaker, and then moving with the spatula the metal oxide, adding until excess, and stirring with glass rod. So we're adding the acid, heat the acid, this is the beginning, to speed up the reaction. This is speed up the reaction. Then number 2, add excess of metal oxide on the acid. Okay, so add excess. What's meant by excess? More than enough. How can we know this excess? Solid appears down. Why you heat the acid? To speed up the reaction. So the explanation, I'll make it now by the blue. Heat the acid to speed up the reaction. Then adding excess. What's meant by excess? More than enough. How can we know this excess? Solid appears down. We can say solid appears down or no more solid dissolve. Then, why are you adding in excess? Why are you using excess? To make sure that all acid reacted. Then, if we take more than the amount of acid, not to be accurate, not a problem. Explain why. Why it is not a problem if we have the acid not accurate volume, because we are using the metal oxide in excess. So if we adding more acid or less acid, there is not a problem because you are using the metal oxide in excess. So after that, heating acid to speed up the reaction, add excess of the metal oxide to the acid. For preparation, the salt, we are using the, the red color. For explanation, for the question, we are using the blue. So for the first one, heat the acid. Number 2, add excess of metal oxide and the acid. Number 3, filtration. Why you are making filtration? To remove excess of metal oxide. Number 4, crystallization. Heat the solution till crystallization point, allow to cool, then filter, and then dry. So why are we added acid in excess, so metal oxide in excess, to make sure that all acid reacted. Excess means more than enough. How can we know this excess? Solid appears down or no more solid dissolves. Then we make filtration to remove the excess. Then crystallization. Heat the solution till crystallization point. How can we know that crystallization point had been reached? Mixing with glass rod, crystals formed. Allow to cool, then filter, and then dry. Drying between 2 filter papers to prevent melting of the crystals. So for heating, how can we know? That crystallization point had been reached, mixing with glass rod, crystals formed. Then after that, the drying between two filter papers. Why we didn't dry an oven or Bunsen burner? To prevent melting of the crystals. We can say to prevent melting of the crystals, or to prevent broken down of the crystals, or to prevent losing water of crystallization, any one of them. So to prevent melting of the crystals. How can we transfer the metal oxide by using spatula? Why we didn't steer with spatula? We know that the crystallization point had been reached, mixing with glass rod, crystals formed. Why we didn't dry in a Bunsen burner to prevent the melting of the crystals? How can we transfer the metal oxide by using spatula? Why we didn't stir with spatula, not to react with acid? After that, what is the difference if we use metal carbonate or active metal instead of metal oxide or hydroxide in this experiment? The first difference, no need to warm the mixture. Because the reaction is exothermic reaction. So no need to warm the mixture because the reaction is exothermic. Number two, reaction stopped when gas stopped. For the first one, we are adding excess to make sure that all acid reacted. If we have metal or metal carbonate, so we have, in case of metal, we have hydrogen gas evolves. In case of metal carbonate, we have carbon dioxide gas. So in case of metal or metal carbonate, no need to warm the mixture because the reaction is exothermic. And number two, we are not adding in excess because the reaction stopped when the gas stopped. So if we use metal or metal carbonate instead of metal oxide or hydroxide, there's two differences. No need to warm the mixture, and the reaction stopped when gas stopped. This is the first one. Number two, in case of titration. So how can we know that we will use the first step or the first experiment that we have base with acid, solid, metal or metal oxide or metal hydroxide or metal carbonate, transition, solid. The second one, we have both of them aqueous, alkali and acid, both of them aqueous. Then, in case of titration, you will find that we have burette. We are filling the burette with acid till 0. Then, known volume of alkali, known volume, like 25 centimeter cubed or like that. Known volume of alkali, and then adding indicator and make experiment. At the beginning,
Doctor, I have a question.
okay,
دلوقتي in some marking schemes okay بيقول لك إنه universal indicator not acceptable و like
if the solution is colored, I'll make it now.
لا هو لا يعني it's not acceptable لأنه هو بيتغير بسرعة جدا يعني it gets lighter and lighter فبيقول إن الأحسن يعني نستخدم methyl orange هل ده صح؟ أو
Indicator,
phenolphthalein
indicator differ from universal indicator.
yeah I know
Indicator, methyl orange, all phenolphthalein. Okay, but universal indicator like pH value. Okay, indicator is a methyl orange and phenolphthalein that we'll use now. Universal indicator like pH value. Universal indicators that we have 1 or 2 or 3 red, 4 or 5 orange, 6 yellow, 7 green, 8, 9, 10 blue, and after that purple. But in case of colored solution, we are not using universal indicator. Universal indicator, not indicator. To prevent interference of color. Okay, I'll explain now. Don't be worried.
okay
Titration for the first step, fill burette with acid. Number 2, known volume of alkali. Number 3, add indicator, suitable indicator. Indicator you have methyl orange or phenolphthalein. If you are using methyl orange, the color change from yellow to orange or red. Phenolphthalein, pink to colorless. After that, we are dropping from acid to the alkali until drops from acid until the color change. The color change, it depends on the indicator we use. Until the color change, if we use methyl orange, we will say until the color change from yellow to orange. In case of phenolphthalein, until the color change from pink to colorless. After that, repeat the experiment without indicator. Why you are using indicator and why you are repeating without indicator? We are using indicator, it is used to indicate the ending point. And then you are repeating without indicator to obtain pure crystal. After that, make crystallization. Heat cool filter dry. So again, for titration, you are filling the burette with acid, add known volume of alkali, take suitable indicator like methyl orange or phenolphthalein. After that, by dropping acid to the alkali, you will find that the color will change. When the color change, we stop. then repeating without indicator. The color change from yellow to orange if you're using cell orange. In case of phenolphthalein, the color change from pink to colorless. Repeat without indicator and then make crystallization. We are using indicator to indicate the ending point. We are repeating the experiment without indicator to obtain pure crystals. Number 3, precipitation. In precipitation methods that we have two soluble salts, they are mixing together. Two soluble salts. Then adding water, then stir, glass rod. So we are adding water, stirring, then make filtration. Filtrate and residue. If we need the crystals of filtrate, we will make crystallization. If we need the crystals of residue, we will make pause then dry. So at the beginning, add water to the mixture. Number 2, stir until dissolved. Number 3, filter the solution. After we make filtration, if we need the filtrate, crystallization. If we need filtrate. If we need the residue, wash with distilled water, then dry. This is for the third one. So we are adding water to the mixture, stir until dissolved, then make filtration. Then if we need filtrate, we make crystallization, heat, cool, filter, dry. If we need the residue, wash and dry. After that, for using catalyst, we have two experiments for the catalyst. How can we know this is a catalyst? And how can we differentiate which one is better catalyst? How can we know this is a catalyst? We will make experiment 2 times without catalyst and with the materials that we are decided that's catalyst. You will find that the rate will be faster and the mass of the catalyst doesn't change. So how can we know this is a catalyst? After doing the experiment, you will find rate faster, mass or weight of catalyst doesn't change. In case of, if we have 2 materials or 2 substances, and then which one is the better catalyst? In this case, for fair comparison, you have same amount of the catalyst, same amount of the material will add it, same room temperature, and then we are comparing the rate. You will find that in case of the faster rate is the better catalyst. After that, for the concentration of acid and base, or acid and alkali. Which one is more concentrated? Which solution or which one is more concentrated? In case of acid and in case of alkalis. We are making the comparison for both. If we have two acids, I'll make comparison. If I have two alkalis, for sure comparison, same amount of alkali, same amount of acid, and then same indicator. After that, the conclusion. In case of more concentrated acids, the less volume of acid used, the more concentrated acid. In case of alkalis, the more volume of acid used, the more concentrated alkali. The opposite. Again, for example, here we have two acids. This 10 and this 20. And then we are doing titration. You will find that in case of 10 and 20, this is the more concentrated. Less amount of volume used is the more concentrated. While in case of alkalis, the more volume used is the more concentrated. So we make like that. This till 10 and the other one till 20. This one is the more concentrated. The more concentrated acid. In the other one, for the alkalis, if you have like that, this 10 and this 20. The more volume of acid used, the more concentrated alkali. After that, for rusting, the more rusting, which one prevent rust? For fair comparison, same amount of water, same period of time, same mass of material used. This is for fair comparison. We are making, for example, 3 test tubes contain same amount of water, same amount of iron nails, same period of time. And then, at the beginning, to take the weight before rust, then weight after rust, then the heavier one the more rust. Which one prevents rust? The same, and then conclusion. The same weight before and after rust, the best inhibitor. For fermentation, this is anaerobic respiration. Here we have airlock, and then glucose, yeast, and water. Glucose is a source of ethanol. Yeast is enzyme, not catalyst. Enzyme or biological catalyst. And then water. Airlock for anaerobic respiration. Allow carbon dioxide to get out and prevent oxygen to get in. So this for anaerobic respiration. Observation that you'll find: temperature rises, exothermic reaction. This is number one. Number two, bubbles of gas. After we are making fermentation, you'll find that glucose changed to ethanol. So it will be ethanol and water and remaining of yeast. So how can we make separation? Number one, we will make filtration to remove excess yeast. For the yeast, you'll find that this enzyme or biological catalyst have optimum temperature. After 40, it will be denatured or destroyed. So we have remaining of the yeast. We'll make filtration to remove excess of the yeast. Number two, fractional distillation. To obtain ethanol from aqueous ethanol. So as a beginning, we have airlock for anaerobic respiration, allow carbon dioxide to get out and prevent oxygen to get in. Adding water, glucose, and yeast. Yeast is enzyme or biological catalyst. You will find that temperature rises at bubbles of gas. After that, for separation, we're making filtration to remove excessive yeast. Number two, fraction distillation to obtain ethanol from aqueous ethanol. Cracking. For cracking, we have cracking of alkane to obtain alkane and alkene. In this case, you'll find that for cracking, that we have a test tube that contains alkane and alkene, like that. We have Mineral wall that contains hydrocarbon. The mineral wall, the using of a mineral wall to hold liquid inside and prevent splashing. After that, we are making cracking. These aluminum oxides is used as a catalyst. You will find that bubbles produced. After finish experiment, we are removing the delivery tube. Why we didn't put off the fire? Because we will prevent back suction or sucking back of the water that cracks the tube. Here we have cold water and this now is hot. So for returning back of cold water will crack the tube. So after we finish the experiment, we will find that we're removing the delivery tube to prevent the cracking of the tube. And the using of mineral wall to hold liquid inside and prevent splashing. For collection of gases, we have three methods. Passing through water, this in case of that the gas is insoluble in water. Downward delivery in case of the gas is denser than air. Upward delivery when the gas is lighter than air. And for drying gases, the left delivery tube must be immersed and the right must be above. All gases are drying by concentrated sulfuric acid except ammonia with lime. Why we didn't dry ammonia with concentrated sulfuric acid? It will react with ammonia. So all gases are drying with concentrated sulfuric acid except ammonia with lime. For the notes of paper 6, why we are washing the glass, the burette or glass water between experiments, you will find that to remove any trace of the liquid. For measuring units, we have time to measure the stopwatch, balance measuring mass, thermometer temperature, for volume, pipette, burette, measuring cylinder, and gas syringe. In case of electrolysis, you will find that for electrolysis, we are using measuring cylinder or test tubes. We can't use gas syringe. For the error and improvement and reasons for that, using measuring cylinder, this error. So we are using pipette or burette. The improvement, this improvement explanation more accurate. For temperature in glass beaker, we are using polystyrene cup to minimize heat loss. If we are making experiment once, repeat experiment several times to take the average. In case of chromatograph paper, the origin line must be drawn with pencil because graphite is insoluble in water. The origin line must be above solvent to prevent stability of spots. And stability requires the solid to decrease the particle size and increase surface area to make the reaction faster. In collection of gases, upward delivery tube if the gas is lighter than air. Downward delivery tube if the gas is denser than air. Passing through water if the gas is insoluble in water. Gas jar and measuring cylinder. Gas jar without the scale, so it's used to collect gas only. While in case of measuring cylinder is used to measure and collect the gas. For drying gases, we used concentrate sulfuric acid except ammonia using lime, calcium oxide. The delivery tube must be to be immersed, while the right delivery tube must to be above to allow gas to escape. In titration experiment, you will find that in different concentration of same acids, the less volume of acid is the more concentrated acids, while in case of alkalis, the more volume of acid, the more concentrated alkali. In colored solution, we didn't use the universal indicator in colored solution to prevent interference of color or mixing of colors. For the smells, we have for alkane, alkene, hydrocarbon, disinfectant smell or smell like petrol. For alcohol, disinfectant smell or antiseptic smell. For carboxylic acid or ethanoic acid, smell like vinegar. For ammonia, pungent smell. In neutralization process, we are heating the acid to speed up the reaction. For the precautions should you take when dealing with acid and base, wearing gloves, lab coat, and eye goggles. And then for the mixture stirred with glass rod and not with a spatula to react with the acid. How to know that we reach crystallization point? Mixing with glass rod, crystals formed. The crystals dried with filtered papers, not in oven, to prevent losing water of crystallization, or to prevent losing, or to prevent melting of the crystals, or to prevent broken down of the crystals. Why we adding acid in excess? The way we add metal in excess to make sure that all acid reacted. What is meant by unreacted solid excess more than enough? It is no matter if the volume of acid is not accurate because we use solid in excess. How do we know that all acids reacted? Seeing visible solid at the bottom of the beaker. Why we can't use alkali instead of base in this process? Alkali is soluble base. We can't remove the excess. What's the difference in the method? If you use metal carbonate or active metal instead of metal oxide or hydroxide, no need to warm the mixture, and then the reaction stops when bubbles stop. The pH of the salt formed equals 7. About heat change, what will be the temperature of the experiment after 1 hour? Room temperature. Why? Because reaction is finished and heat loss to surrounding. All the reactants are left in the stand in the lab for 1 hour to have room temperature. What happens if the volume of the experiment increased to double? The temperature decreased to half. If we adding volume of the liquid double, temperature would be half. If we add the solid to double, the experiment will be double. Compare, we have a difference between them both. For example, this is a cup of water. Then, if I'm asking you, what is the difference if we add 1 spoon of sugar to a cup of water, or to be 2 spoons of sugar, this to double concentration. If we have 1 spoon is putting in 2 cups, so it will be half concentration. Again, if we're adding more solid to the solution to double, the reaction will be double. If we add more solvent, so it makes it diluted, the reaction will be half. So concentrate. You are adding solid or liquid. For the solid, double, reaction double. Solvent double, the reaction will be half.
دكتور انا ما فهمتش اللي هي الحته بتاعت السوليبل الكلي
أي سبب الألكلي؟
فوق شويه اللي هي الكلي is a soluble base
Okay.
remove excess.
For the first process we have neutralization or excess. Okay, for neutralization or excess we are adding an excess, so it must be insoluble. In case of alkali, we didn't use it. For alkali, we're using titration, not neutralization. Why we didn't use alkali? Alkali is a soluble base, so we can't remove excess. يعني في الميثود الأولى اللي كانت عندنا كان في عنده بيز، فلو في حاجة ما دابتش هتبان نقدر نعمل لها separation. لكن في الالكلي بيدوب كله، هقدر اشيل الاكسس منه ازاي؟ In case of neutralization, we are using base, not alkali. Why? Because base is soluble and we can't remove the excess.
اوكي طب دكتور ما فهمتش حته السولفنت اللي هي اللي كنت حضرتك لسه بتشرحها.
اوكي. في السولفنت في الكونسنتريشن بشكل بسيط عشان تتخيلوا اللي بقوله، لو عندي بقول كاب اوف ووتر وفي سبون اوف شوجر، لو خليت السبون دي 2 سبونز اوف شوجر يبقى انا خليت الكونسنتريشن كده ايه؟ دبل. اوكي؟ طيب لو خليت بقى بدل ما هي كانت سبون لووتر لكاب اوف ووتر، حطيت لي سبون في 2 كاب اوف ووترز، يعني حطيت 2 كاب اوف ووتر على بعض كده وحطيت عليهم سبون واحده اوف شوجر، يبقى انا كده خليت الكونسنتريشن ايه؟ هاف. يعني بشكل بسيط انا عايز اقول لك على موديل بسيط قوي. انت النهارده لو عامله لنفسك كوبايه شاي وهي تشربي الشاي ده، فحسيتي ان السكر بتاعه قليل، قدامك ايه؟ حل من الاثنين، يا تروحي تزودي سكر يا تروحي تزودي ميه على الشاي. هتعملي ايه؟
هزود سكر.
اوكي، يبقى كان ليس كونسنتريتد انا عايزاه مور كونسنتريتد. طيب انا عملت لك شاي وحطيت لك فيه سكر كتير، فانت قلتي لا 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 ده كتير عليا. طيب في الوقت ده عملت ايه؟ قمت مزود ميه على الشاي عشان اعمل ايه؟
دايليوت.
دايليوت. وبقى عملت ايه في الكونسنتريشن؟ يبقى
Okay.
let decrease the concentration. Okay? So for increasing solid, increase concentration. Increase liquid or solvent, decrease concentration. Okay?
Okay, thank you, doctor.
You are welcome. After that, for 1 hours, okay. For graphs of rate of reaction, as the temperature or surface area or adding catalysts are used, the rate of reaction will be faster, but the final volume will be the same. Rate affects speed, not amount. Rate affects speed, not amount. So for the rate, you will find that the speed will be faster, the time will be decreased, but the total volume must be the same. For example, if I have two reactions, one of them using catalyst and the other one without catalyst, you will find that this one catalyzed or have more surface area or increasing temperature, the final volume will be the same. After that, if metal or acid or amount of reactant are changed, different volume is produced. For example, if I have 2 grams and then you are using 4 grams, you'll find that the curve will be changed. For the amount of the table, acid and base, drops of liquid at the top of the tube, it means that this for the table, the question 3, paper 6 for the table. For conclusion, if you have drops of liquid at the top of the tube, this means that, or positive test of water, this means that hydrated. Condensation at the top of the tube, or positive test of water, this means that hydrated. Or positive test of water, it means that contains for anhydrous copper sulfate, color change from white to blue, or anhydrous chloride from blue to pink. This means that this hydrated, contains water. A black solid that crystallizes, the decomposition of hydrogen peroxide, this transition metal, or catalyst, manganese oxide. Test on filtrate, this means that water soluble. Test on residue, this means water insoluble. While the salt and solution is colorless, non-transition. Colored salt, it means that transition metal and catalyst. pH 1 or 2 or 3, or the color is red, this means that is strong acid. It is not correct if you said acid. Strong acid. 4, 5, 6, orange or yellow, this means that weak acid. 7 or green, this means that neutral. 8, 9, 10 blue, weak alkali. 12 till 14 or purple, this means that strong alkali. Burning magnesium, color change from gray to white ash. Burning of copper, color change from brown to black. And we said that you must know all the color of copper. We said that copper is brown, copper oxide is black, copper carbonate is green. All salts of copper are blue. So copper brown, copper oxide black, copper carbonate green, all salts of copper are blue. Okay, Ahmed, pause the recording. In case of electroplating and purification, this application of electrolysis. Application of electrolysis, we have extraction, purification, and electroplating. For electroplating, we are using, if we want to make electroplating for a ring, so the ring will be cathode, and then the silver will be anode. For example, the silver must be anode, and the ring will be cathode. And then the electrolyte must be aqueous solution of the anode, and it must be completely immersed like that. Aqueous silver nitrate. You must say aqueous or solution. So aqueous or solution. At the beginning, number one, clean the metal ring. Number two, connect the ring with cathode. Number three, connect silver with anode. Number four, use aqueous copper sulfate, silver nitrate, sorry, aqueous silver nitrate as electrolytes. Number five, rotate the ring during electrolysis or during electroplating. Number six, remove the ring, then dry. For the questions, why you are cleaning the metal ring? To allow silver to stick. To allow silver to stick on it. Rotate during electroplating for uniform plating. We didn't use it frequently. We'll need recoating. Again, so at the beginning, how we make electroplating for the ring, connect the ring, clean the metal ring, connect it with cathode, connect the silver with anode, use aqueous silver nitrate as electrolyte, rotate the ring during electroplating, move the ring, then dry. Why we clean the metal ring? To allow silver to stick on it. Why you make rotation for uniform plating? We didn't use it frequently, we'll need recoating. After that, for purification. For purification of metals, we have pure copper and impure copper. The impure copper must be anode. The impure copper must be anode, and pure copper must be cathode, and then aqueous copper sulfate. Then we are writing connect the impure copper with anode, pure copper with cathode, aqueous copper sulfate as electrolyte, and then oxidation takes place at anode and reduction takes place at cathode. You will find that at oxidation, soluble impurities will dissolve, the insoluble impurities will precipitate down, and the copper will be moved to the copper. Then copper precipitates down and it will be removed and cleaned. For extraction of metals, the electrodes must to be carbon or graphite. Electrodes, carbon or graphite, is a non-metal, or platinum is a metal. And then for extraction, we have molten or aqueous. In case of molten, we have only one gas. One gas is produced at anode. Like NaCl, it will produce Na and Cl2. And then observation, you will find that bubbles of gas and bulb turns on. If the solution be cold, the light turns on. In case of aqueous, if we have active metal from K to Al, and if we have less active from Zn to Cu. In case of active metal, like NaCl, water H and OH, it will be H and Cl. So two gases are reduced at the two electrodes. While in case of less active metal like ZnSO4, H2O, it will be Zn and O. Only one gas is reduced. In case of this aqueous concentrated, in case of aqueous diluted or aqueous acid, two gases are produced. In case of diluted like water, NaCl diluted or H2SO4 diluted, so as it is water, positive and negative, it will produce hydrogen and oxygen. Two gases are produced in diluted hydrogen and oxygen. While for the acids like HCl, positive, negative, to produce chlorine and hydrogen. So we have now for one gas in molten, or if we have active metal, less active metal, one gas is produced. Two gases are produced. One gas is produced in case of molten or aqueous concentrated less active metal. Two gases produced in case of aqueous concentrated more active metal, or in case of diluted solution, or in case of aqueous acid. two gases are produced. While in case of molten or aqueous concentrated, one gas is produced. Okay. Ahmed, pause recording.